In the last video, we talked about how perpendicular bisectors worked and the two theorems that coincide with perpendicular bisectors. Today what we're going to be doing is we're going to be working with the same idea of the perpendicular bisectors, only using angles. So an angle bisector is a ray, line, or segment that divides an angle into two congruent adjacent angles. Alright, the distance from a point on a line is the length of the perpendicular segment from the point to the line. So for example, we have the angle bisector, which in this case is PS, which is creating two congruent adjacent angles, QPS and SPR. Okay, and the length of the perpendicular segment that they're just talking about is this QS and this SR right here from the point to the line. Okay, so that's creating this 90-degree angle right here. So if you look really closely, we actually have two right triangles created by this angle bisector and the angle. All right. So with these two vocabulary words in mind, we can then discuss what our theorems for the day are. We have the angle bisector theorem and the converse of the angle bisector theorem. Okay, so the angle bisector theorem states if the point is on the bisector of an angle, then it is equidistant or equal distance from the two sides of the triangle. So, meaning if we have an angle bisector right here and we have 2 points on the line and they're both meeting at this one point, in this case D, that means that DB is congruent to DC. Okay? Alright, and then the opposite of that, the converse of that, is if a point is on the interior of an angle and it is equidistant from the sides of the angle, just like this, then it lies on the bisector of the angle. So in this case, instead of proving that these two angles are equidistant to each other, we're just saying that we do in fact have an angle bisector present in this particular picture. All right. So with those ideas in mind, we actually have some examples we can go through. So we have find the measure of angle GFJ. So we're trying to find this mystery angle right here. All right, well, by definition, we know that we have two equivalent or congruent segments here that both meet at this similar point. So with that being in mind, we actually are using the converse of the angle bisector theorem, proving that FJ is an angle bisector, which by definition means that it's splitting this angle in half. So since we know that HFJ is 42 degrees, then angle GFJ also has to equal 42 degrees. Okay? All right, so same thing, we have find the value of P that would make P lie on the bisector of the angle. So if this particular point did lie on the bisector of the angle, if we were to draw a line right here, then these two parts would actually be congruent to each other. So we can actually use algebra to solve this. So we could make x plus 3 equals 2x minus 1. Our x is on one side and our numbers on the other side, so then we'll have, if I subtract x from both sides, I'll then have x equals, add 1 to both sides, 4. So x is going to equal 4. We can plug that back in. We'll just do the easier one. We'll plug it into x plus 3. So these sides are actually 7. All right. All right, and then the last example we have is find the value of x. Same exact idea here. Because we know that these are congruent and that these are creating perpendicular or right angles, excuse me, we can do the same thing. We can say, well, 5x equals 6x minus 5. Subtract 6x from both sides. 5 minus 6x is negative 1x, or negative x, equals negative 5. Get rid of those negatives, and x equals 5. All right, and since that's all we need to know, we just have to say the answer is 5.